All right, first part to every problem is let's figure out what it's asking for. So in this one, they want us to maximize revenue. So therefore, I need an equation that has revenue in it. So what equations do we know with revenue? Well, we know profit equals revenue minus cost. Or we also know that revenue is equal to the amount we sell something for times the number of them that we sell. So let's go back to the problem and see if we can figure out which this is talking about. So here we go. We see that there's a baseball stadium that holds 54,000 spectators with ticket prices at $9. Ooh, so there's money. There's money. Okay. So that could either be, we'll see how that fits. So it's $9 and the attendance has been 2,000. So what I'm seeing here is if a ticket's $9 and the attendance is 2,000, I'm getting a money and a number of people coming to the game. So I'm getting a number of items we sold, how many tickets we sold, and how much we charged for them. So that means we're using this equation. So goodbye, revenue and cost. And you can also verify that. Does anywhere in the problem talk about costs? No. Does anywhere in the problem talk about profit? No. So probably a good guess this is the one we want to do. Now, if that's enough to get you going, stop the video and try it yourself. Now, we're going to try to build two equations. One equation dealing with money and another equation dealing with number of tickets sold. So let's go through the problem and find these values. So we know that let me zoom out a tiny bit more. We know that with the ticket price at $9, okay, so therefore the price is $9. There we go. The average attendance was 2,000 people. I'm going to come back to that because I'm going to focus just on money. When the price dropped, here's the key word, price dropped. This is a change. So we're going from 9 to something else, and then it's going down, so therefore that's a subtraction. And it's dropping to 6. So would I write that? Well, no, because that wouldn't drop it from 9 to 6. That would be take away 6. So what do I need to do? I need to drop it 3. Now, but the assumption here is we're trying to figure out what would be the best. This is just one example. So I'm going to actually stick a D next to that, where I'm going to say let D equal the number of $3 price drops. So therefore, if I let D equal 1, that means we've had one $3 price drop. So similarly, if I let D equal 2, if I substitute in 2, that would mean we have two $3 price drops. And that makes sense because if I substituted in 2, that would be 3 times 2, which would make 6. So we'd subtract $6. Okay, great. Fantastic. So, so it's very important to define that D so you don't get confused later. Now, if that's enough for you, if you're like, oh, the money one made sense, stop the video. Try to do the number of tickets sold on your own. Okay, so number of tickets sold. Don't get this 54,000. Don't let that distract you because it's not saying they sold that many seats. They're saying the stadium holds that many people. So if our revenue it will be maximized by selling more than 54,000 seats, you're stuck. You can't. The stadium can only hold 54,000. So we're done. So let's just keep that in mind. That's helping you with your final answer. So right now, we just know attendance, when we sell $9 tickets, attendance has been 20,000. So therefore, I'm starting at 20,000. Now, how is that changing? Well, when we dropped to $6, the average attendance rose to 27,000. All right, so rose, that's a plus. So that's a plus. Now, and how much did it raise? Did it raise 27,000 or did it raise to 27,000? It rose to 27,000 people, which means that's a plus 7,000 people. And that is per one drop. So therefore, if we were to do 2 drops, the assumption would be that it would go up 14,000, right? If we lower the prices even more people will come, hopefully. So we're going to go ahead and finish that off. And now we have revenue. And we have our revenue equation. This is wonderful. So then how would we find what would maximize it? Well, in calculus, we have learned the key to maximizing means take your first derivative. So I'm going to leave you there. So you take your first derivative, you set equal to 0, you do all that work, and get your answer. And then make sure you answer the question that's being asked. Is this problem asking you for what D is equal to? No, it's saying what ticket price. So once you get your D, because once you're solving for D. If you got D equals 7, then where are you going to go back to figure out what the ticket price? Well, that one makes sense because then D would be like negative. Let's do 1.5. If D was 1.5, so therefore I'm going to go back to the ticket equation, right? The 9 minus 3D, the price equation, right? And figure out what the price would be when I do 1.5 drops. Now, I don't know if 1.5 is right. I just made it up off the top of my head. So I hope that helps you get going.